This is the 2007 6 to 8 level paper 2, where we have some interesting questions which test out a variety of our mathematical knowledge. First question is a pie chart, where the first thing we have to do is work out the scale factor, because we have to convert the units of people into a number of degrees. So we add up the people, and then we have to just work out what we need to do to turn that number into 360, because in the whole circle is 360. This is a nice easy number, usually they are, so that total number of people is 60. All we've got to do is times that by 6. This then gives us some fairly nice easy units. We've got the hard one done for us. We've only got to add the 90 degrees for no newspaper, which leaves us with 60 degrees for evening. Next question looks at our algebra. We've just got to remember that between the 2 and the x in the expression y equals 2x, there's an invisible times. So whenever we multiply anything by a number, we just write it as 2x or 3x. So what we want to do is to get y. And the first one we know it's 2x, add 5. So we write that as 2x plus 5. Next one's simple. Basically, we repeat the idea. So why not times it by 3 and add 1. So this will give us 3x plus 1. We can multiply by 4 and subtract 3 if we want. And this can be written as 4x minus 3. Now it might be that our number x, we don't want to multiply it at all, we want to divide it. So what we'll do is we'll have x over 2, we write it as a fraction. Then if we need to add a number, we plus 11. Note, if the line actually went underneath both the 2 and the 11, the x and the 11, then you'd be dividing both bits by 2. But in this case, the line only goes underneath the x. So the only thing we're dividing by 2 is x. This one's an absolute classic. Turns up a lot at GCSE. We want to find the area of a shaded part of the diagram. But what we always do is realize that it's a lot easier to find the area of the whole rectangle and then just take away the areas A and B, which are triangles. Area of a triangle is half the height times the base. So all we've got to do is do 3 times 5 and divide it by 2. 3 times 5 is 15, half of it 7.5. So the shaded bit is made up of the whole thing, which is 50 from the 5 by 10. And then we take away 2 7.5s, which is the same as taking away 15. So we're left with 35 centimeters shaded in. Turns up a lot, something you'll see a lot of. So whenever you see something that's shaded, you want to find the area, just look for the shapes around it and start taking them away. Next one, we've got 2 lines of algebra, and the only difference between one line and the next line is that one's one bigger than the other. But because we're going smaller, we're going from 6x plus 2, all we do to go to 6x plus 1 is take 1 away. So we do that to one side of our equation, we do it to the other. So this is the basic idea of equations. They're a balance, and what we do to one side, we do to the other. So on the second half, we square one side, so we'll square the other side. But we know what 10 squared is. It's 100. Next one, we're looking to do rounding. And basically what you're looking to do is to get a line after the 4th decimal place. The 4th decimal place is the 5. If you draw a line after it, we ignore the digits, but we do look at the digit after that. And the digit after the 5 is a 9. So So we've got to round it up. So our 5 turns into a 6. Next one is really, how do we compare things? And what we're comparing to is a decimal number. So we've got to convert all those fractions into decimal numbers, which is quite easy to do with our calculator. Then we can compare the resulting number to the 7 digits we're given at the top, and we can see very clearly that 355 over 113 is virtually identical to 3.145927, and therefore that is the right answer. Next one, what we're doing is we're making everything 3 times bigger, but what we actually do is 2 times bigger because it's twice as big. We look at how big the distance between our centre of enlargement and a particular point is, and if it's scale factor 2, we double it. Then once we've got one point of the shape, we can basically draw the shape in very easily just by doubling the length of all the sides, because that's what the enlargement is telling us to do. Next one, we've got some basic algebra, and what we've got to do is look for our value of k, and we've got to realize that we can look up there and see that we're actually saying 30 is the same as 2k, so k is 15. Next one's always a tricky one. C is more than D, and everyone's looking for a whole number, and of course you can't find one. In this case, it's actually is 5.5 and 4.5 of the 2 numbers. We want the bigger one, so C is 5.5. We look at the next one, and if 2 numbers add up to a number, then one of them has to be bigger than the other. Now it tells us that E is more than F, so it has to be more than halfway towards 10. So it must be greater than 5.